Welcome to the Genetics Podcast. I'm Patrick, the co-founder and CEO of Sano Genetics, and I'm really excited to be here today with Debbie Kennett, who is the first guest on the show that is a genetic genealogist. If you don't know what that is, you're about to find out, but I'm really excited because I've followed Debbie on Twitter for a long time. I've read her blogs, and if you didn't know it, actually probably the biggest driver of adoption of direct-to-consumer genetic testing is genetic genealogy, and I'll let Debbie explain exactly what that is. It's great to have you on the podcast, Debbie.
Thank you for inviting me.
So just to get right into it, would you mind explaining what genealogy is, what genetic genealogy is, and how you got into it in the first place?
Okay, so genealogy is essentially the researching the history of our families. So sometimes we draw a distinction between genealogy research and family history research. Genealogy tends to be focusing very much on the names and the dates of your ancestors, but most of us are actually family historians, where we don't just look at the names and the dates, but we also like to paint a picture of our ancestors and find out about their lives and the social history. So the genetic genealogy actually combines the tools of genealogy with the DNA tests. So we can use DNA testing as a way of testing hypotheses about, say, relationships, or for finding connections with different cousins from around the world. And sometimes also it can show up surprises when people don't match with the cousins that they should be matching, or they discover that they've got, say, half siblings they knew nothing about. Or we also do have cases where people test and they discover that their father is not their biological father. So it's, as the databases are growing, it's really opening up a whole can of worms, but also providing a very, very powerful tool for reuniting families and providing answers which people couldn't previously get from any other means.
Yes, absolutely. And I think we'll go into some of those, maybe unexpected uses when it comes to using databases to solve cold cases, find criminals in the US, and some of the implications of those. But also there's the obvious, implications of helping people find family members, learn more about themselves. So you were originally a genealogist, not a genetic genealogist. What got you into it in the first place? And then when did you kind of start to look at genetics as an interesting tool?
Right. So I started back in about 2001, 2002, researching my family tree. And then I ended up having a particular interest in my maiden name, which is a very rare surname, Cruise, spelled Cruwys. And I became much more interested in that name than all the other names. And so that developed into what is known as a one-name study. And that's where, rather than just researching the surname within your own family, you research all the people who have that surname wherever they may be in the world. And that led me to joining the Guild of One-Name Studies. And we had a number of members at that time who were starting Y chromosome DNA projects. And at that time, we only had the Y chromosome DNA tests available. So Y DNA testing is actually very, very useful in a surname project because the Y chromosome follows the all-male line of inheritance. So normally the Y chromosome is passed on with the surname. So if you test two people with the same surname, you can see if the results match, and then you know that they share a common ancestor.
Right. So your father's last name was Cruz.
Yes, that's right. Yes.
Because you inherited your Y chromosome from your father, and then him from his father, and so on and so forth. You can sequence the Y chromosome and kind of paint a line just along the male lineage, and then you can use the mitochondria to do the same for the kind of maternal lineage. Is that right?
Yes, except of course I don't have a Y chromosome, so I had to take my father. And
right.
My mitochondrial DNA represents my mother's line, my mother, her mother, and so on. And I can also test my father's mitochondrial DNA, but that represents his mother and all her female ancestors. By DNA testing, we have to find a male relative with a surname of interest to take the DNA test on our behalf.
So how many other people do you know that share the same surname or maiden name? You said it's quite rare, but I suppose you've been able to find people over the years.
There's probably only a couple of 100 of us in the world, but
right.
What you tend to find with rare surnames is that they are generally a subset of a more common surname. So there are different spellings. So once you start
Right.
spellings like CRUSE or CRUISE, like Tom Cruise, and that starts to increase the pool of people enormously. And there's another variant, Cruise, CREWS, which is very, very common in America. So I've actually got a large number of American cruises in my DNA project at Family Tree DNA.
Right. So were you one of the early adopters of direct to consumer genetic testing? Was it quite clear to you when the first companies started to offer this testing that there were going to be databases of people that were looking across the world for distant relatives, or has that come as a surprise to you and others in the genealogy community?
Well, with the Y chromosome DNA databases are still relatively small. There's something like 800,000 Y DNA results in the family tree DNA database, but I've been there right from the start with autosomal DNA testing, which is the one that is more useful for finding these connections with cousins. And that was introduced in 2009, first of all by 23andMe, who introduced a feature called Relative Finder. And then in 2010, Family Tree DNA launched their Family Finder test. And certainly in the early days, I don't think we would have anticipated the databases getting as big as they have done. I mean, I can still remember 23andMe announcing that they were trying to get 1 million people in their database, which was unattainable in those early days.
Yeah, people were laughing about it, right? Saying it was impossible to be that many people.
But I think one of the things is that the tests were comparatively expensive. And I remember when I got my first Family Finder test, and I tested both of my parents, I think it was something like $200 for each of the tests. So it was really only the real keen, hardcore genealogists who were buying these tests and just thinking and hoping that one day the databases will become large enough to be of some use.
Right. And that has been one of the, maybe in retrospect, expected, but I think at the time, maybe unexpected drivers of this industry, right? My understanding is that more than half of people who buy a 23andMe test are primarily motivated by learning more about their ancestry or genealogy. Is that the case, or is that kind of an urban legend?
It's difficult to get true figures on this. I mean, certainly when when 23andMe expanded their database, they were not even able to offer their health test for some while, and they actually considerably in that period, and that was purely driven by sales of ancestry tests. And Ancestry DNA, the largest company, their focus is primarily on family history, but the thing that does seem to have been driving a lot of the sales is this desire to know who you are and where you're from, and to get these pie charts with your comparisons of people from different parts of the world. And there was I don't know if you remember, a video from Momondo a while back, which went viral, and that really helped to drive interest in the Ancestry DNA test in particular.
How much can you say about the accuracy of these pie charts? Because you hear, I mean, everyone likes to criticize them, and I think when it gets down to small percentages, it seems like sometimes it isn't accurate. But from what I've seen over the last 10 years, especially the mainstream tests like Ancestry or MyHeritage or others are getting actually quite good at picking out at least kind of country or continent level ancestry. But what's your view on it? Is that part kind of quite solid and ironclad?
I think it's improving all the time. There's science behind. There is good science behind the tests, but a lot of it was drawn originally from science which was looking at populations and not at individuals. But companies have actually done their own research, and Ancestry actually published a landmark paper a couple of years ago, which was the impetus behind their genetic communities feature. And they are now able to assign individuals to quite distinct regions around the world. So if you have Irish heritage, for example, they've got 100 regions within Ireland that they can assign you to.
Right.
Very, very good accuracy. And that's using a different method from these pie charts where they're looking at shared segments of DNA. And if they tell you that you belong to the County Kerry community, then it's, the chances are that you will have some ancestors from County Kerry.
How does that work exactly? What do they do?
So it's looking at genetic networks of related people. So they compile these huge networks of people who've got connections, sharing, say, a sizable chunk of DNA, and it may be that one person matches a number of people in that network, and then that person matches various other people in the network. And then once they've identified these networks, they then look at the family trees of the people in the network and try and identify, if they've all got particular locations in common.
Right.
So they've got over 1,000 of these networks now. So, and it's revealing all these migratory patterns. So you've got like sort of Scottish people in Nova Scotia and all these settler communities in Australia and New Zealand and various communities all across the North America. That part of the test is actually much more reliable than the high level percentages that people get, which I think can often mislead people. So at the broadly continental level, the results are generally correspond with people's known ancestry. So, sort of African, you can distinguish between, say, Northern European and Mediterranean, or sort of Asian. But once you start to get down to the country level on those, they become less reliable, though they are improving, I think. They're much better than they used to be. But also it depends on where you're from. So if you're European, you get much more granularity than if you're African or Asian. So results for Africans in particular can be really, really disappointing. And I've seen, for example, someone from Ghana who ended up being assigned 85% Nigeria. And when I looked at his results, it turned out that the company didn't have any reference samples from Ghana at all. So it can only be matched to the populations that are in the database.
We've had a couple conversations on this podcast about the issues with lack of representation in genetic databases, and it has implications in health, but also in ancestry. And it seems like it's a problem that's not getting solved anytime soon. Although a lot of people are working on it, it continues to lag behind in people of ethnicities or ancestries that are outside of continental Europe, basically.
Well, I think what needs to be done is the research needs to be done in those countries. We don't want, like people going into Africa and sampling DNA to help rich Americans or rich Brits who want to know how much African DNA they've got. The research has to be done in those countries for the people who and dealing with their priorities, which are generally health research rather than ancestry testing.
Right. One of the interesting, so you have quite I suspect you have quite a complicated schedule because you're an honorary research associate at University College London. You, as you mentioned before, you're a member of the Guild of One Name Studies. You also run a very popular wiki, and we're one of the founders of the wiki for the International Society of Genetic Genealogy. And you've also written a couple of books, and one of the books, DNA and Social Networking, I think it'd be interesting to talk a little bit about, because these are two forces, if we think about direct-to-consumer genetic testing in 23andMe, Ancestry, and others, was popularizing around the same time as some of the large-scale social networks. So how have you seen those two forces come together, and what are people using genetics and social networking to do?
Right. So in fact, it's interesting that since I wrote that book, so much has changed, and just in the last 10 years. So some of the social networks that I wrote about in the book just no longer exist or just aren't used anymore. So things like Google Plus has been and gone, and Facebook has become ever more powerful. And we're finding that Facebook is actually a very useful tool for genealogical research, and also for identifying people, because what you tend to find is if you're trying to find living people, you can usually find them on Facebook, and if they're not on Facebook themselves, they usually have family members on Facebook. Quite often the family members will publish genealogical details. They will talk about birthday parties, or they'll be wishing other relatives happy birthday or talking about weddings. So I think a lot of people are publishing all sorts of facts about their family on Facebook, often not realizing that they're publishing publishing things publicly, and that
Right.
information can be very useful, sometimes for useful purposes, but also for more malign purposes as well.
Yeah, I've witnessed there. I mean, there are dozens, probably hundreds around the world of different groups of people that are organized around connecting with lost family members on Facebook, or using Facebook to do research. I've seen guides on how to, if you encounter someone on Facebook who you think might be a relative based on surname, geography, etc., different strategies around how to reach out to that person or engage in a way, that isn't kind of strange or out of the blue. So it's a whole, I mean, for people who haven't been involved in this, like me, it's a whole different kind of subculture and approach. And I understand there's even there's conferences like Roots Tech that goes on in London, where people, thousands of people come together and discuss some of the new technologies. And I think you've been involved in that before, haven't you?
Yes, we had a big Roots Tech conference in London in the autumn last year, but in fact, the American version has just finished in Salt Lake City.
Right.
Something like 20,000 family historians from around the world who've descended on Salt Lake City for that conference. These conferences are getting bigger and better every year, but in some ways, I think the Salt Lake City one is perhaps a little bit too big now for its own.
Right. And I think one of the other interesting kind of trends alongside living people being DNA tested is scientists are getting much better at sequencing ancient samples, right? So people that are long dead, thousands, or in some cases kind of several thousands of years old. Have you seen this starting to also influence the way we understand ancestry and migratory patterns?
Yes, well, I think that's been a really transformative area of population genetics, because we finally have a way of directly testing hypotheses, and it's really transformed our understanding of our prehistory. Previously, the sort of prevailing theory was that humans didn't really move around very much, and now we've seen from all this ancient DNA that those migrations have just been constant, really, throughout human history. Right. And we've had all these amazing discoveries about Neanderthal and Denisovan introgression and ghost populations, these populations that we know exist in theory because we can see the traces in our DNA, but we don't actually have any ancient DNA samples from those people.
Right. So one of the big kind of stories of, stories, if you're interested in this kind of stuff like I am, but of January, February this year was everybody looking at the data and realizing that many of the direct consumer testing companies, 23andMe, Ancestry DNA, sold a lot fewer new tests in the Christmas season than they were expecting. I was wondering if you have any thoughts on why this is. So it's been growing every year, and it's seeming like it's starting to not grow quite as quickly. Is it that the early adopters in terms of health and genetic genealogy and other applications are starting to saturate, or is it concerns about data privacy? And it'd be great to talk about some of the the debates around how databases are being used in the US. I'm just wondering if you have any theories as to why the purchase of these tests has started to slow down.
I think there are probably a number of factors involved. I mean, firstly, we know that all new technologies, the growth pattern typically follows an S-curve, where it's slow to start off with, and you have a very steep rise as everyone starts to buy into the technology, and then it starts to plateau. And I think certainly in the US market, we are seeing that plateauing of sales, but we don't seem to be seeing the same slowdown outside the US, from what I can see. There's certainly, I was at a conference in Belfast just a few weeks ago. There's certainly a lot of interest there, and we're still seeing lots of growth in other countries as well. But we're also a few years behind the curve anyway. So Ancestry, the biggest company, launched in the US in 2012, but it was 3 years later before it started to launch in other countries.
Right.
But I do think that there are issues with privacy concerns, and I think there are two factors involved. And I think the law enforcement issues possibly do have some bearing on that. But I think also there is a lot of public support for law enforcement usage of these databases, and that, in theory, could have actually encouraged more people to test who probably wouldn't have considered testing before. But the other thing I think is various scares about companies selling off data, and that a lot of that's actually been driven by inaccurate reporting, because the headlines always seem to say that all these companies are selling your data to pharmaceutical companies, but they're not explaining that in fact that's not what's happening. People can choose whether or not they want to opt in to participate in research, and then only if you consent, your data can then be shared with the companies who are partners with, say, 23andMe or Ancestry. And in fact, what I think some people don't realise is that a lot of people do really want to share their data, and they enjoy participating in research and contributing to the greater good. And it's always presented in the media as though it's a really bad thing that companies have access to our data, but it's not at all.
It's really interesting because what it seems to me that it matters to people is that the communication is clear and they have choices, and they're able to transparently understand what's happening. And some companies do this really well, and some really don't do a very good job of it. Because I think you're absolutely right that if you actually ask people ahead of time, most people do want to support research. They just want to make sure it's done in a way that they can understand what's happening and potentially share in the value in some way.
Mm. One of the other concerns I think is probably particularly in the US, is when you've got an insurance-based healthcare system, people are worried that that their genetic results are going to affect their insurance. Although you do have things like the GINA law in the US, which protects for most cases. It's just I think is it disability insurance and
life insurance as well. I think
yes.
So let's go more in detail, because I think you put it really well with the law enforcement issue, that there's I think a very coherent argument for both sides, which, if I can give kind of my very basic kind of view on what the debate is, but you'll know more about this, so you can kind of tell me where I'm wrong and fill in the rest of the details. But there are large databases that people have willingly put their DNA data into for the purposes of matching with potential relatives or distant cousins. These databases in the last few years have started to be used by law enforcement in order to solve cold cases where they have the DNA of a murderer or a rapist. And the famous kind of case that kind of started this whole thing was the Golden State Killer, that they used a genetic database to find a relative of that person, and then ultimately track them down using, I suppose, more kind of conventional policing techniques. But the issue here is, I suppose, one of slippery slopes, right? That many people can agree on using it for things like the Golden State Killer, but there's a whole kind of spectrum of crimes in between that and something that could be a human rights abuse that people are worried about oversight. Is that kind of the crux of the issue, or are there other pieces of it that I've missed?
Well, I think that the big crux of the issue is relating to consent. So when the news of the Golden State Killer case first broke, the site that was used was GEDmatch, which is a third-party website. So they don't actually sell tests, but if you've tested with one of the major testing companies, you can upload your data from, say, Ancestry DNA, and your cousin who's tested at 23andMe, they can upload their data and you can compare your results. Now, at the time, GEDmatch had a sort of rather ambiguous privacy policy, which didn't specifically disallow law enforcement usage, but it didn't explicitly state that was what the database could be used for.
Right.
So there was a reaction at the time that a lot of people felt that this is something that should only be done with consent. The terms and conditions of GEDmatch have changed a number of times in the last year or so. And first of all, they adopted the policy of trying to make sure everyone was aware that this is what the database is being used for, to give people the option of opting out. And then in May last year, they decided they would start from scratch. They would opt everyone out. And then at that point, everyone would have to opt in specifically to participate in law enforcement matching. So the database went overnight from it was 1.3 million to 0, and at the moment only about 200,000 people have opted back in again.
Right, which is actually a big number in a sense. I mean, that means in the rate at which we open and respond to emails today, getting 200,000 out of 1.3 million people to do anything kind of does speak to those 200,000 people being motivated by this, right?
Yes, that's right. But another difficulty is that there were a lot of people who, after the news of the Golden State Killer case broke, deliberately uploaded to help with these law enforcement cases.
Right.
Forgot about it. So any default options, they tend to be sticky. People just stick with whatever it was when they just signed up with the company. So it's much more difficult to motivate people to go back and change settings, whichever way round it is.
That seems like a good approach to me, the kind of opt-in, the opt-in approach. Were there a lot of people calling for that?
There were, yes. And I think that was the right thing to do. But then we also had the situation with Family Tree DNA, who went the other way round. And first of all, when they discovered the FBI were trying to use their database, they decided that they were going to allow it, and that everyone, first of all, there was no opt-out when they first announced this, and then there was an uproar about that, and then they were able to introduce an opt-out within about 6 weeks or so. But now going forwards, first of all, they opted out all the EU users from March last year, but then going forwards, everyone is now opted in, and they have to proactively opt out of law enforcement matching. So that again is controversial because, of course, there are people who perhaps have been in the database for a long time. Their email addresses don't work anymore. They probably don't realise how their data is being used. Right. The justification for that is that the rights of the victims should take precedence over the rights of the individual, because there are 100,000 unsolved cold cases in America. So you've got huge numbers of families affected by these cases still waiting for answers. But I would argue that, in fact, one of the things that has come to light because of these genetic genealogy cases is the shortcomings in the criminal justice system in America, because so many of these cases could have been solved if conventional testing had been done.
Right.
For example, there are 2 cases now where the perpetrator identified had been executed in Texas, and DNA testing was mandated by the state at the time, but these prisoners were not tested. There have been other cases where the suspect had a long criminal history, but again, even though the DNA should have been taken, it wasn't. And you've also got all sorts of arguments about whether or not DNA should be taken upon arrest, for example. So in the UK, we routinely, the police have the power to take DNA upon arrest for any what's called recordable crimes. So that could be something even like drink driving. But when the police have taken DNA from someone from drink driving, sometimes it's uncovered someone who's a serial rapist.
Right.
In America, it's much more controversial to take DNA upon arrest. But then you now have a situation where you've got a whole country who are effectively connected by their third cousins to someone on GEDmatch. So you've got this sort of vast network now that spreads out and ensnares an entire nation effectively.
Right.
To my mind, I think there needs to be a more discussion and debate about the bigger issues involved. And the other thing that's a complete travesty is that there's huge numbers of sexual assault kits that haven't been tested. There's huge numbers of convicted offenders who haven't had their DNA tested. I just saw a report the other day, 30,000 convicted offenders in Washington state alone who that are legally required to submit DNA, having committed an offence, and are still not in the database. So, I mean, genetic genealogy has solved, well over 100 cold cases, but if you test 30,000 convicted offenders, you would solve hundreds and hundreds of cold cases.
Right.
And I just find it incomprehensible that there's not a public outrage at this complete failure to tackle these huge backlogs.
Right. So we're sort of debating the wrong thing to some extent,
so,
right?
Yeah.
Yeah, that's interesting. I've never heard that before, and it makes complete sense, especially given there's myriad issues with genetic testing in the U.S. as well. There, as you're saying, samples that haven't been tested, but there's also a ton of cases that the DNA testing was done incorrectly, or the expert witness really wasn't an expert, and the wrong person ended up in jail or put to death in some cases.
Yeah. Yes, so doing the right testing at the right time there are so many people who've been falsely convicted and who could be exonerated through DNA testing, and there have been cases where the police won't even allow the testing to be done, and even for people on death row, they won't allow the testing to be done. Do we know
what the kind of policies or past with companies like Ancestry DNA or 23andMe? If GEDmatch had about 1.3 million people, my understanding is 23andMe and Ancestry have 10 times that, in the US. So they could conceivably, you could identify almost anyone in the US by a third or second cousin from those databases. But my understanding is they have taken quite a firm stance that they won't allow law enforcement to use it. But I think they can be compelled to in some cases if they have a warrant, right? Do you know if there are any, has there been any kind of definitive stance made by any of the very large companies?
Right. So both 23andMe and Ancestry have said that they would fight any warrants or try and limit the jurisdiction. Both companies publish transparency reports where they publish information about requests for law enforcement access. 23andMe has a database of 10 million. Ancestry have a database of 16 million. 23andMe have not received any requests for access to their database for genetic genealogy searches. Ancestry had one request last year, or in fact it may have been earlier this year, which they resisted successfully on grounds of it was an overreach of jurisdiction. To be honest, I cannot see how a broad search warrant could succeed, because you're not asked if you want to upload DNA from a crime scene, you haven't got evidence that the criminal is in the database. You're looking for their relatives, and normally, if you have a search warrant, it would be to get someone's, say, credit card information, or because you think that your criminal is actually in the database. So it would be unusual use of a search warrant to ask for such broad access. And also, all the databases are international. So to me, it would seem unreasonable for, say, a judge in America to grant access to an international database, giving access to people in all sorts of different countries to solve a local crime in one particular US state. There
Absolutely.
was a search warrant for GEDmatch, but that turned out to be not a broad search warrant. It was one that was submitted just after the database changed and the opt-in was introduced. So the detective had already had access to a number of matches and was effectively asking for a warrant to get access to those matches again.
Right. Do you know how different it is in the UK or other parts of Europe? Are projects like the UK Biobank or other large or even direct-to-consumer testing companies, is there any level of interest in using these kind of resources over in this part of the world?
For law enforcement access, you mean?
Yes, for law enforcement.
Well, things seem to work very differently in Europe. Yeah. There is a saying that Europe regulates and America innovates.
Right.
What seems to happen is that in Europe, we want to sort of get all the regulations sorted out before going ahead and deciding on how to do things. So there are various pilot studies. So there was one in Sweden where they just published recently where they did some next generation sequencing on a crime victim. And that's led to an investigation going on in Croatia, because the victim turned out to have been from Croatia. But that study was published in a peer-reviewed journal. And I've been involved in a pilot study in the UK, which in fact has just come out in the last few days, where rather than using crime scene samples, we were given 10 individuals with anonymous identities to see how many of those we could re-identify. And they were all individuals associated with the forensic science company Eurofins. And we were able to identify 4 out of 10 of those people. And that was just using GEDmatch at the time before the opt-out, when it was about 1.3 million people. So that was actually a much higher success rate than I'd anticipated in advance.
Yes. So how did you do that? What you just had the DNA, is that right?
So we were given the GEDmatch IDs. They uploaded the profiles for us, and then it was just a question of using the matches, using clusters of matches, and building out the family trees to try and work out the identities. So one was very easy because there was a mother and a father in the database, and we did that within just a couple of hours.
Right.
Matches were more distant, but once you start getting clusters of matches, so in one case, for example, there was a whole cluster in Shetland, and the same ancestral couple came up in all of the trees, and then it's just a question of building the trees down and then finding an intersection between that cluster and then another cluster that also appears in the as you're doing the research, and you end up with, so each person has their own mix of genetic relatives, and it gets to a point where only one person or one person and their siblings could actually have contributed that particular pattern of genetic relatives to that profile.
And I know there are other approaches that actually use the Y chromosome to try to predict a last name. Did you use that as well, or is that kind of a completely separate approach?
We didn't have access to Y-DNA, but that I'm a bit wary about using Y chromosome data on its own, because especially with the forensic samples, they only test a very small number of markers, which means that you could end up with matches with lots of different surnames.
Right.
Just using the STRs, short tandem repeats, can also produce false leads. It's much better if you combine the STRs with the SNPs with Y-DNA data to get better accuracy. But also, you've got the risk of what we call non-paternity events, and there's it's roughly 1% to 2% per generation. So even if you've correctly you may have come up with a surname lead, it's quite possible that the person doesn't even have that surname anyway, even though it may have appeared somewhere in the distant past in their family tree.
So on average, about 1% to 2% of births, the father is not who maybe the child suspects it is. Is that right?
That's right. But then on top of that, you've also got, like name changes. People get married again, or say the father marries again, they adopt the stepfather's name, and people change their names for all sorts of reasons. So you've never got any guarantee that it's going to be the same surname. And there have been cases where when Y-DNA has been used on its own, it has led to false leads, and that happened in the Golden State Killer case, where they had a very I think they only had 12 markers, and they targeted someone in a nursing home and tested him. And they really should not have done that, because it just wasn't a good lead at all.
Yeah. And there have been a couple of kind of famous historical examples, right? Or I don't know if they're true or not, but there have been some whisperings about different kind of question marks along different royal lineages and those sorts of things as well, right? And probably someday when we have 10 times as many people in the population that have been tested, we'll start to be able to piece together some of these things, right?
Yes, well, quite a lot of the royal Y chromosome lineages can be inferred anyway by testing other people, but there was famously the case of Richard III, and when they did all the comparative Y chromosome testing, they had 5 descendants from the Duke of Somerset, I think it was, and 4 of those all matched each other, but the 5th one didn't. And
Right.
when the Y chromosomes from all 4 of those men did not match the Y chromosome for Richard III, so that shows that there was some break in the link between the surname and the line of descent,
Right.
In that royal family tree. But that is only what you would have expected after all that time anyway.
Right. It's just after that many generations, it's potentially inevitable, right?
Yes, that's right. Yes.
I know we're kind of running up against time here. Before we finish off, I wanted to ask about some predictions for the future. And I know you've been part of a number of different interesting research programs, but one of those is about donor anonymity in gamete donation or sperm donation, fathers, mothers, sperm or egg donation, and that people are using direct consumer genetic testing to actually find information about their ancestors. And I think this is a kind of unprecedented and interesting kind of new direction that this has taken. I was wondering if you could just talk a little bit more about that and maybe some other predictions for the future as we move into a world where most people will have a genetic test and could conceivably be part of large scale databases.
Right. So, the issue of donor anonymity, I think, is resolved, and it's now fairly obvious that anyone donating sperm should not be guaranteed anonymity because it's it can't be kept. So, in fact, what that is leading to, first of all, anyone who is donor conceived, they now have a good chance of discovering their donor origins. But it's also leading to a new approach to donor conception. And in fact, I'm attending a workshop in March this year in London, where people are talking about their experiences of open donations. So there's a group called Pride Angel, for example, where they actually encourage people to donate, but actually to be part of the family. So it becomes a new way of starting a family. So
that's wonderful. Yeah.
Involved in the family right from the start, or at least the donor is known right from the start. And I think that is where this field is going to move to. But also there has to be much more openness about fertility treatment, because there's always been this stigma about it, and you see all these celebrities, women having babies in their sort of late 40s. But they're not revealing that they're using donor egg or donor sperm or whatever, and it makes it seem as though it's just very easy to have a baby at any stage. Whereas in fact, the research shows that you really, if you want to have your first baby, you have to have it before 35, and if you leave it too late, and if you want a second child, if you start at 35, it becomes much more difficult.
Right.
There has to be. In fact, one of my colleagues at UCL is involved in a campaign to increase education about fertility and increase awareness about fertility and the need for women, if they want a family, to start much younger, because women can't have it all. They can't have a career and then suddenly decide at 35 or 40 they want to have a family. It's much more difficult to do that. So I think that's a bigger societal change that needs to be made, where we recognise this and perhaps change career structures so that because at the moment all careers are structured around women having careers and having babies much later. And in fact, I was speaking to a doctor a while back who works in the National Health Service in the fertility sector, and he was saying that in a generation he's seen a change in the consultants now coming in. They're having the baby first before wanting to then go on and have their career as a consultant, because they've seen the experiences that their parents went through in the previous generation.
Right. And I think it's going to continue to change, isn't it? That as new technologies come in, we'll hopefully be able to figure out a way to make it all work.
Yeah.
Yeah. Well, wonderful. I know if people want to keep in touch with you, you're on Twitter. You've got your name, Debbie Kennett, which is pretty good. That means you were probably pretty early to the Twitter phenomenon. And then they can also follow your blog, which is Cruws, CRUWYS.blogspot.com.
Yep.
Anywhere else that I should direct people, especially if they're interested in genetic genealogy or following your work?
I would just direct them to the ISOG website and the ISOG wiki in particular, which is just isog.org. and that will lead to the wiki. There's a link on there.
Great. Well, wonderful. Thanks so much, Debbie. Really appreciate it. I certainly learned a ton today.
Okay, thank you for inviting me on.